welcome to our weekly podcast on real-time AI and Java with myself and Aaron. And then, of course, today we have special guests too. But first, we'll kind of do some housekeeping. So yes, Aaron.
Yes. Hey, thanks, Mary. It's great to be back. Sorry we had a little bit of a week off there. In the U.S. we don't get many holidays, but when we do, we got to take advantage of them, right? So
I agree. That was truly Labor Day. We can rest. So
Yep.
yeah,
But
awesome.
but hey, today we have Cédrick on with us. Cédrick, how you doing?
I'm doing great. I'm so happy to be with you. I've been watching all the episode, so I'm
Thank
thinking
you.
I've catch up. I know what ML and
Yeah,
real-time AI should be.
awesome. Yeah. So very nice. Yeah. So wonderful. So yeah, we can have Cédrick introduce himself a little in here, and then we can let
Yeah,
Cédrick take
and
the
then you
stage.
can
Right?
you
Yeah,
feel free to run the show there, Cédric.
that's right.
Yeah, sure. So hi everybody. If you have been on this YouTube channel, you probably know me now. So I'm developer advocate. I've done a lot of workshop with you all, and I'm really happy to be back to talk about AI ML. And if you know me, I'm also super happy to show that you can do everything with Java.
Yeah.
Yep.
So without further ado, I will start sharing my screen, ask everyone if you see my screen, and I will do a little demo and talk about what you can do now with Java. All the materials are available to you. We will share the link in the description below. It's a GitHub repo, the code and material, everything is there. Okay, so what I would like you to demo today is actually something called retrieve augmented generation. So full generative AI. I want to ask a question to ChatGPT and ChatGPT to answer me, but in the question, I will add my own data. Just ChatGPT is boring. I would like to insert some data in my own database, and when the response come back, I have context coming from this database. So to do this little demo, you need IDE environment. This is what you find in the middle. I will use my own laptop, but everything has been set up for you to run in Git or Gitpod, so nothing to install. We will need OpenAI, so the ChatGPT guy. We will ask him to do the chat completion request like you do with the web UI on ChatGPT, and also another API called the Embeddings API that will help create the vector. And on the other side, we have our database. Okay. So to set up this environment, first you need an Astra account. So here in the README, you have everything you need to first create an account, going to astra.datastax.com, signing either with GitHub or Google. And once you are in the UI, you just have to go quickly to settings on the top left-hand corner, click token management, select organization administrator over here, and click generate token. And so with that, you will get a UI with the token in front of you. And the key we are using is actually the token. So in Astra, the token is really your API key, and you can do everything with that key, especially because we set privilege of organization level. Okay. All right. So if you have done things okay, so you open Gitpod, then the Astra CLI is there for you. And you can directly go Astra.org, and you should be able to see that you are already connected to your organization. If you're not connected, Astra, setup, -- token, and provide the token you just copy in the UI, and you should be ready to go. And with that, you can immediately start creating a database. To do our demo, we need that database. So you will do Astra DB create, and see the command is over there for you. Astra DB create demo GenAI, which is the name of the database, -k GenAI, which is the name of the key space, -- vector, to make sure that vector capability, what we are demoing today, is enabled, and -- if not exist, to avoid any error.
So you can create a vector database right from the command line like that? That's pretty
Yes,
cool.
you can.
Mm.
Yes, you can now.
Okay.
And it's new.
Yeah.
So if you're not in .4 of the Astra CLI, yeah, please upgrade. And once the command is done, you can do Astra DB list, and you will see that the database is there. I did that already to gain some time, and you can see here the last is demo GenAI, deploy on GCP, and this little checkbox means that it's a vector database. So here another command to describe what the database look like. But you set. With that, you have your Astra account, you have your Astra database ready to go. There is no table, no data in there yet, but we will handle the other guys first, OpenAI. Okay, so let's go. So to use the ChatGPT API and so OpenAI platform under the hood, you go to OpenAI platform. So I think it's something like platform.openai.com. You sign in either with GitHub or Gmail. Sounds familiar, and you end up in that UI. Then on the top right hand corner, click here on your name, and you should be able to see a page called View API Keys. You create a new key, and same as before, you copy the value of the key. Then what I ask you to do is define this key as environment variables. So copy paste and replace your key. For privacy reason, I will not show you my key, but assume that this key is there on my environment. Okay, so if I'm coming back here, let me go back to the slide. So here we have now the vector database running. We have an OpenAI account and an API to start using the key. So it's a Java project, no surprise. Actually, it's a Spring Boot 3 project, and I created it using the Astra archetype. So not reinvent the wheel. Use the archetype, add the dependency to vector, and you're good to go. So if I want to show you what the code looked like before running the test one by one, so here I'm on my IDE. In my POM, I've added Astra SDK. I also added the OpenAI client. It's not on you to create a client to interact with OpenAI. There's multiple libraries available for you. So OpenAI Java, this one, the one reference on the OpenAI platform. You can also use something called OpenAI for J. Those two are clients wrapping the OpenAI REST API.
I didn't know there was an OpenAI for J. Is that new?
OpenAI.
Yeah, it's new. I think there are also multiple. I've seen others, people just generating their own client based on the specification, right?
Huh, that's awesome.
Yeah. So this app is using the SDK. So you, by providing some environment variables, we will be able to connect to the proper database. And for the generative AI here, I set up a few keys. One is which model do we want to use? So for create the embeddings, we are using a model called text embedding ADA 2. And for the chat completion, hey, no surprise, ChatGPT, GPT 3.5 Turbo. And so OpenAI, each LLM model you are using has its own dimension. So in the demo you did previously on this session, Aaron, you have 11 or 14 vector size dimension to show you exactly what's happened in a vector. Real life LLM are using dimension like 1536, Vertex AI using 768. So it's pretty big. So with that, I'm able to instantiate the OpenAI client using the environment variable, and I'm able to instantiate something called vector table. So it's coming from the SDK, and it will provide me all the method I want to use to interact with my vector, namely doing search. Okay. And my second table is very, very basic, just the main Spring Boot. So now what I will show you is I will execute one by one some unit tests and show you what it is. Okay, so first I want to validate that I can connect. So Astra client, SQL session are objects that allow me to connect. So I want to execute should be connected test. And so here, each time I give you the command to run. So here I go. I run the command on my terminal and see if I can connect to my database. So you see the log that's coming. And here we go, success. All right. Second, I want to test if I actually can connect to OpenAI. So to see if I can connect to OpenAI, I want to run that flow. Let me make it bigger for everyone to run. I want to have a sentence like hello world, use my OpenAI Java, talk to OpenAI's REST API server to vectorize, build me a vector out of this sentence. This operation is called create embeddings, because a vector is also an embedding per se. So the output should be a vector, and I should log my vector in the console. So to do that, I have here dedicated unit test. So I importing my OpenAI client, see, very basic. And I will call the method called create embeddings. And I provide two sentences. This is a sentence. This is a second sentence. So let's run that and see what we have. So here I have should create embeddings, right? So copy, go here, clear, paste, here we go. Let me go here. And if it's okay, we are good, because on one end, we can connect to OpenAI, create vectors. And on the other end, we have a database empty, ready to have vector. So what do we need to do now? We need to populate the database, if you wish. And to do it, we will use this time this flow. So instead of getting the output in the console, I will give the output to my vector table for my vector table to save it. It's simple as that. And instead of providing just a string, I give a JSON document. And here we go. So here I have a first method called ingest document that will loop over the entry on my JSON. So JSON is here. Okay, it's a quotes from philosopher. So I'm looping, and for each quote, I'm invoking vector table dot put, and it is as stupid as that. So it run. It take 1 minute or so to run, but I already have run that command. So my database is populated, my table is populated. So I can show you what it looks like by going Astra DB. I should have that somewhere. Astra DB SQLSH here. Okay. Just to show you what is GenAI demo GenAI.
Live demos always happens.
Yeah.
See, I can prepare, but even nevertheless.
Yeah.
And so if I select maybe okay, star from philosopher, which is the name of the table we choose together, limit 1, just to see what it looks like. So the vector is super long. It has been computed for me. But here we also have an ID. We have the text that have been picked from the JSON. And we have used some metadata because in the JSON, we were able to say who wrote this code. I put it here as author.
Nice.
All right.
So, Cédrick, which version of the Astra CLI are you using? I thought I updated mine, but I still get all kinds of weird characters when I try to select a vector column.
Okay, so I'm using 0.4, so
0.4,
Astra version. Sometimes you need to delete a repo on here. So you should not have, but if you go here to the hidden repo Astra, here there is a folder called CQL/sh Astra. That's the CQL/sh that is downloaded from the repo.
Oh, so sure.
If that folder already exists, it will not be replaced.
But then it doesn't do it, right?
If you dump this, it will download the new version.
Got it. Good tip. Good tip. Thank you.
It's the same for DSBug, by the way, because you want to load stuff there. Okay, and now my table is populated, right? So I should be able to run search, similarity search based on vector. And here, this is what I do have. I have a couple of search, and which is cool. It's the vector table doing it all for you. Vector table provide a method that is similarity search, where you provide the text you are looking for, the how many record you want, and the metadata. So here, if I go here and show you the similarity search function, similarity search. So here, based on what you provide in the query, I will build the proper select. But for doing a vector comparison, I still need to take the sentence you provide as an input and transform it as a vector. And to do it, I redo exactly the same that we just did. If you look at this method, it's very, very basic. I'm using, again, the embeddings coming from OpenAI. So here, compute OpenAI embeddings. So you give me a string, I ask OpenAI to give me the associated vector, and I put the vector in my query, and then I just ask vtable.similarity search. And it will create all the Cassandra and all the magic for things to happen. And here I have a couple for you in that test. I have the default search, which is just search code. I have search code adding the author. I have search code adding a tag. You can also add a threshold. Let's say you want always something about 0.8, very, very similar stuff I need. This is for you to put how close you want to be to your result. So if I pick any of those, and for sake of time, maybe I should just take one randomly. Let's say filter by author. Okay, this one. And here you will just execute the test, compute the vector, and execute the similarity search. And this similarity search is the same that Aaron did in the previous session. It's just using CQL, select, yada, 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 and order by ANN, and you provide the vector.
Now, is this one using a cosine based index, or did you go with dot product, or which one did you use here?
Here I'm using dot product.
Oh, cool.
But I think using the default similarity, it's a cosine sinus is good enough.
Yeah.
Actually, if you go to the similarity search here, you can see that this is on you to provide which distance you want. And the similarity matrix, here you have dot product, cosine, and Euclidean. So
Okay.
pick what you want.
That's cool.
The framework allow any, but it seems like cosine is the go-to, the more performant.
Yep.
Yeah.
Do you
The product.
are there other methods or mechanism to besides cosine and the dot product? I guess there are there like additional way of doing this other than these?
Yeah. So you think about vector as think about 2D. Vector are just real mathematic vector with 2D.
Right.
So if you want to compute the distance in between those vectors, you can go with the dot product, which is in mathematics called L1. You can go with L2, which is the square root of the difference of the coordinate put at square. You can compute the cosine. It's all the mathematical formula that you can use to
calculate.
Compute the distance in between two vectors. Here in Cassandra, as of now, we have 3. Dot vector, Euclidean, which is L1, I think. So no, Euclidean is L2, dot product is L1, and cosine is cosine. But there are more. You can probably come up with your own distance if you want to, but it will not be available.
These are the ones. Okay.
Okay. The last piece I have for you today was now that based on something, you are able to retrieve something very close. Well, you can ask the system to say, okay, I would like you to generate some codes as is it was Nietzsche or as is it was Plato. What he will do is he say, okay, so this is here, let me go here and find the latest. So here, instead of providing a text, I will just ask you, hey, can you now generate a quote with the same way to speech as Nietzsche, dealing with politics and virtue? That's pretty cool because now he will do the stuff. So first things first, we are looking for in the database for quotes coming from Nietzsche that used to talk about politics and virtue. And now we will go in and ask ChatGPT, okay, generate me a quote that is similar to all the context you provide. And for that, you are using this time the chat completion API, the second one. So if I go here and here, now what we are doing is, so now you ask what you want to do. So first thing, the Astra vector will fetch from the database all the existing codes that look like what you want to do. It's your context, retrieve augmented context. And then it will ask OpenAI Java client to ask the chat completion API to generate a code, but not out of the blue. Generate code coming from Nietzsche, and this is 4 samples of Nietzsche quotation. So please respect that way of thinking, that way of talking when you give me back the response. And if I want to run that demo, because it's pretty cool, I will shut that, find the quote over here, and go to the very bottom, which is, please generate me some quotes with RAG. And here we go. Okay. So actually generate 4 because we ask for. So all these 4 is what Nietzsche could have said about politics and virtue. So, and with that, we did the full thing. We did ingesting document, similarity search, and creating something new, ask something new to ChatGPT, providing a context.
Very nice.
Well, that's awesome.
Very nice. Yes. Thank
Here,
you.
let me put your your GitHub repo on the ticker there. That way people can find that. I tell you, I'm definitely going to go ahead and walk through that myself. This was pretty awesome.
Yeah, definitely.
And it's just the beginning. As you know, as our viewer can tell, Java is lagging behind regarding to Python. So that stuff, it's mainly Python, and they are running in front of us. And most of the time, people does not really use the embeddings and chat completion request APIs directly.
Yeah.
They are leveraging a third-party framework. And viewers might be aware of that. It's a famous name like LangChain, Llama Index, Semantic Kernel, Fez from Google. There are plenty. And what we need is actually, you should be able to use Astra with LangChain. Boom.
Yeah.
So use LangChain as you regularly do, and now is Astra populating what's needed for you. And so we did that first in Python. It's a framework called Cassio. So you can go to cassio.org and see that we have integrating a lot with LangChain for chat completion, from templating, memory chat, semantic cache, key value cache, and many more. Sure. What you've seen here with Astra SDK Java Vector, I'm reusing totally the same concept. Sure. So, okay, I did it with Java, but all the brain power actually came in the first place from Stefano Lottini from DataStax to actually build the Cassio framework in Python. So him, in a way, I'm porting and maybe reviewing, challenging, because there is a lot of Cassandra data model involved under the hood.
Yeah. Very cool. Yeah. That's wonderful. Yeah.
So maybe in a future episode, I can come back and show you now that the Java stack is also integrated with LangChain. Maybe
Java
version. Right. That's right. Yeah. That's
good. Yeah. Cédrick, we'll definitely have you back in, for another episode for sure. Yeah. I know there's so much you wanted to show us, but we only have so much time.
Every week. Yeah.
I mean, it's a lot. Now you can go back and look at OpenAI, look at what is a similarity search, try it, see what's. Yeah, you need to learn that step by step. It's definitively a lot of things to learn.
That's right. Yeah. Wonderful. Yes. And then before we go, just wanted to share with everybody, because Cédrick also brought up the use of Astra, our Astra database, which has vector capability. Sorry, this seems to be a little blocking the view. But so if you look into your screen, that's in the middle there. That's our QR code. If you want to register with Astra, that's $25 per month, US dollar, for free. No need to give your credit card. So that's very nice. So yeah. All right. So. And I'll just unhide so we can see Cédrick again. So
So of course, Astra is free to use up to 80 million queries a month. OpenAI that I show you is free to use up to $18, but for 30 days. After that, you have to
is there like a rate limit on that for the free tier?
Right. Yes.
I'm trying to remember how that works.
It's hard to tell. Really, I'm not sure. I went into the paid stuff pretty quick because only paid customer could access the most performant model like GPT-4.
That's right.
So yeah, I'm on the paid tier. Maybe also why I didn't share my key in the first place.
Right. You don't want anyone stealing that.
That's right. Yeah. Awesome. Yeah. Okay.
All right. Yeah. Well, Cédrick, this has been great. Thank you so much.
Thank you, Cédrick.
It's always great to be back.
Yeah. Awesome. Yeah. Thank you. Have a great day, everybody. Yeah. And happy coding, happy ChatGPT, happy Gen AI coding.
Chat GPTing, is that a verb
Yeah.
now? Yeah.
That's right.
Yeah,
Okay.
I've been LLM stuff.
Hey, thanks everyone.